Welcome back to the channel. So today we will solve this two sum 2 problem. It is a medium category problem and it is basically an advanced version of the two sum problem where the array was not sorted, but here the array would be sorted in the increasing order, right? So the problem statement is same. We just need to find out the element, the two element whose sum would be the target value, right? So here if we see 2 and 9, 2 and 7, these two, if we sum these two elements, then the target would be 9. Like the summation of these two elements would be 9, right? So and we need to return the index. So if you like see here, the index is one index, right? So we are not starting from the zero, we are starting from one. So this is what here it is explained. And in the problem, if you read, it is given that it is the one index array, right? One index array. And the answer, which would be like between one and the length of array, right? And we need to return these two index. And it is also mentioned that there would be exactly one solution, and we cannot use a same element twice, right? We cannot have a solution, right? Like two, we add up multiple times, right? We cannot use the same element multiple times, and we need to solve this without using any extra space, right? So if you remember the last video of the two sum, we solved this using a map, right? There we use a O of an extra space, but here we need to solve it without using an extra space, right? And this is the input. This I think we covered, right? Let's look into this one. So here also the target is 6 and input array contains 2, 3, 4, and we need to find which are the two element whose summation would be 6. So if we look into here, 2 plus 4, if we add these two elements, the summation would be 6, right? And the index is 1 and 3, right? 1 and 3. So since the index is starting from the 1, so that's why it's 1 and 3, not 0 and 2. Got it? Similarly, if we in this problem, in this input and output, if you see, like, right, the summation, like the target which we need is -1, and if we add up these two elements, then the summation would be -1, right? And the index would be 1 and 2, right? 1 and 2. So this is the uh, problem. I think it is simple, right? Like they have categorized this one as a medium. Why? Because the main trick is we do not have to use any extra space, right? And okay, so what would be the brute force approach? Brute force approach would be we can have two for loop, right? One like start with the index 0, like here, and second one will start from the I plus 1, right? Because we cannot use the same element twice. That's why the second for loop will start from I plus 1, right? And we can keep on iterating and checking if the summation of ith element and jth element is target or not, right? So this would be the brute force approach. Let's bring this to our whiteboard, and let's do the dry run, right? Okay. Um, Let me write the elements over here first. 2, 7, 11, 15, right? And the index is 0, 1, 2, 3, right? And so how the for loop, okay, let me show you the code, and then I will like walk you through this dry run, right? So this is the brute force approach, right? This is the brute force approach. So we have two arrays, two for loop, right? And like I is starting from 0th element and j is starting from the I plus 1, right? And then we are checking if the summation of two element is target. If it is the target, then we are returning I plus 1 and j plus 1. Why I plus j1, I plus 1 and j plus 1? Because we need to consider this as the one index array, but in reality it would be 0 only, right? But since we have been asked to return like this, so we will add up 1 in the output, right? And if we do not find the answer, then we will return minus 1. But this case will never trigger. Why? Because here it is mentioned that there will be one solution, right? Exactly one solution would be there. So this condition will not be triggered, right? So let's do the dry run over this, right? Okay, okay. Let's do the dry run now, right? So, okay. So we are starting. I would be at 0 index, right? And j would be at I plus 1. So j would be here. And then we will check if a of I plus a of j, if it is same as target. So if we add up 2 plus 7, 2 plus 7, is this equal to 9? Because the target is 9, right? So is this equal to 9? Yes, that is correct, right? So this if condition will be true, right? And then we will return I plus 1 and j plus 1. So what is the value of I? I is 0, right? I plus 1. And j, what is the value of j? J is 1, right? So j is 1, j plus 1. So 1 plus 1, right? So this will be 1 comma 1, right? So we will return 1, sorry, 1 comma 2, and that's the answer, right? If you see here, output is 1 comma 2. So I think we have solved this in the brute force approach, right? What would be the time and space complexity? If you see, time complexity would be uh, n square. Why n square? Because we are using two for loop, right? We are using two for loop. In the worst case, it will iterate through the entire array twice, right? And so that's why the time complexity would be O of n square. What is the space complexity of this solution? Space complexity is O of one. Why? Because we are not using any of the extra space, right? We are not using any of the extra space. So space complexity is O of 1, right? And one more thing. So if we submit this problem now, if we submit this solution in the lead code, it will throw TLE, time limit exceed. Why? Because like the cases are like that keep brute force approach will not accept it, right? So what is the optimized approach, right? What is the optimized approach? So if we read out the problem here, they have asked not to use any extra space, right? The solution should be in a constant space, right? Extra space. So we cannot use any extra space, right? And the second thing which we need to notice is the array is in ascending order, right? Array is already in sorted order. So like if we see the sorted somewhere, like whenever the array is sorted, two things trigger to my mind. One is binary search, and second thing is two pointer approach, right? So I think binary search and two pointer, these two are a technique which we can use blindly whenever the array is sorted, right? So what we can do here, we can use two pointer approach and solve this, right? So let me walk you through the code, and then we will do the dry run on the brute force approach. See what we are doing. We are having two pointer, right, at the 0th index, at the n minus 1 index, and we are keep on iterating till the point we are not getting the our required output, and this condition is true, right, where I is less than j, right? And we are using this, right? So, and this solution is like O of n time complexity, and space complexity is also one, and this will get accepted, right? Because this is the optimized approach. So what we can do, we can do the dry run on this, right? So let me clear this board, right? And let's bring these two things over here. So we can have it here, this one, right? And then we can bring this code, right? Okay, so let's start. So the input array is 2 comma 7 comma 11 and 15, right? And the target is 9, right? So here if we see, the I is at 0th index, so I would be here, and j is n minus 1. So n minus 1 is this point, j, right? And the index, let's give the index 0, 1, 2, and 3, right? And then we are checking if I is less than j. Is 0 is less than 3? Yes, that's correct. So we will come here. A of I plus A of j is target. Is A of I plus A of j is target? 2 plus 15 is 9. Like 2 plus 15. Is it equal to 9? No, right? 17 is not equal to 9, right? 17 is not equal to 9. That's why this is not true. So we will, this is not true, right? So so this will not be executed. So like the cursor will come here. Is A of I plus A of j is greater than target? 2 plus 15 is greater than 9? Yes, that's correct. So what we will do, we will reduce the j pointer. Why j pointer? Because in the binary search also, we keep on trying to find the like the target element, and we keep on reducing the right pointer if the target, like the summation of if that particular value is greater than the what we are looking for, right? And similarly, if the mid is lesser than the target element, we keep on increasing the left pointer, right? Because the array is sorted. So similar way, what we will do, since the summation like 17 is greater than 9, so how we can reach to the point where we can find the 9, right? So we cannot like increase this pointer. Like if we increase this pointer, the summation will keep on increasing, right? Summation will not decrease, right? So that's why we will have to um, move this pointer. We will have to move the j pointer, right? Whenever the value would be greater. So will come here, and then again this will start is 2 plus 11, like 2 plus 11. 2 plus 11 is equal to 9. 2 plus 11 is equal to 9. No, it is not equal, right? 13 is not equal to 9. 13 is not equal to 9. So, and 13 is, so this will not be executed. Then we come here, and then uh, 13 is greater than 9, right? So j will again decrease. J will again decrease. So j pointer will come here, right? J will be here. Then again this things will happen, like I is less than j, yes, 0 is less than 1, and then 2 plus 7, 2 plus 7, is it equal to 9? Yes, it is equal to 9. So this condition will be true. So we will return I plus j, I1, I plus 1 comma j plus 1, right? So what is I plus 1? I plus 1 is I is 0, right? I is 0, and the j1 and then j is 1, right? J is 1. I, so it would be 1 comma 2, right? 1 comma 2, and we will get our required output. So this is the optimized approach. So what is the space and time complexity, right? What is the space and time complexity? So if we see here, we are not using any like for loop, like double for loop, right? So the time complexity would be O of n. Why? Because we are just using one for one while loop, right? So at most it will iterate entire array once, right? And that we saw in the dry run also. So the time complexity would be O of n, and then space complexity would be O of 1. Why? Because we are not using any of the extra space. We are just using just a few variables, right? So the space complexity would be O of 1, and if we submit this one, so like lead code will not throw the TLE, right? So you can try this solution, and if you like this content, please do like, subscribe, and share the channel. We'll meet in the next problem. Until then, bye.